typically how button bits have evolved. We used to have in cable tool drilling, our bits were forged at the forge shop and dressed and hardened, and out in the field as you're pounding in the earth, it's very abrasive and that metal wears away, so you'd have to bring the bit up out of the hole and take it off and take it over to your forge, heat it up and pound it all back out to size with sledgehammers, quench it in water to get it hardened again. And a button bit eliminates all that. We've been working on button bits here at Ramp for approximately 15 years now, and we've got a pretty good product. We use alloy steel, and we heat treat it in our own facility, our sister company at Camforge, and we've got buttons that are made in the USA. And when we talk about buttons, wherever that name came from, I don't know if it's a manufacturer thing or not, but these are what is called the buttons. Here's a couple examples. This is a size button that I use in my 8-inch bits, and this is a size button that I use typically in the 4 7/8, 4.5 through 18-inch. We can use. We'll have maybe some of these in different spots, locations, but we can make carbide button bits just like these, clear up to 18-inch and up to lengths 4 feet long would be no problem. So if you're drilling deep elevator shafts or deep large holes, Ramp can fix you up. But what I've got here on display is some of our typical, most common bits. This is an 8-inch bit for a customer. It's actually a 7 7/8, and when I say 7 7/8, that's the actual diameter of the body with the buttons pressed in it. So the tool size used to say with the old forged bits, if you wanted an 8-inch bit, it might be dressed to 7 7/8 or 7 3/4 to go inside of an 8-inch hole. With the button bits, you give us the size that you want the bit to be: 6-inch, 6 1/8, 6 1/4, 12 3/4, you name it, and we can make the size fit. The faces of the bits are designed with quite a bit of thought and process, because you can see there's no real symmetry about the bottom at all. They're kind of spaced here and there, and they're not in a straight line. I learned years ago about that straight line going across here is in a hard rock. I ended up with a target down in the bottom of the hole because I had a button right in the middle and spaced, equally spaced, and oh, it looked pretty. It was a nice looking bit, but it wouldn't drill because the earth was the rock was being pounded on right in here in these open areas. The way these are designed is that as the bit hits the rock, the earth, this button will overlap, or this button will overlap the circle that this one's making, and this one will overlap this one, so they're all hitting in a different place each time, forcing the cuttings out, so you get a hole that's being cut completely around the borehole and not making that target figure. It's cutting new earth every time it hits. The outer corner buttons are somewhat symmetrical, but they're not as important as quite as much as the face buttons. The gauge buttons on the side help for that wear. It helps keep the sides out the gauge over an extended period of time. The corner buttons are important too. That at Ramp, I will place these buttons here so that the tangent point of this button here, the highest part of this crown on the side, matches the size of the gauge button, so you don't have a little funneling or a bullet nose kind of an effect, which might cause your buttons or your bit to stick in certain formations. These bits aren't real great in soft formations like clay, because you're pounding through them so fast that you'll get all kinds of mud up in this upper section. You come out of the hole, you got to shovel that off, so you need a lot of water. But they really show their stuff when you're in rock, solid, hard formations. If you really want to make extra footage per hour with your bit, put the addition of the wing sub on top of the bit, approximately 4 foot long, and it's like extending this water course another 4 feet. Helps lift the cuttings, keeps them off the bottom of the bore hole so that you're not grinding in the same cuttings all the time. Just standing there pounding, making mush, and not making footage. But that's a good example right there of our 8-inch bit. We like, these bits are a little bit longer than what you might find on the market today. These are, I use an overall number of 14.5 inches, one of our most common bits. But I use a nice long and deep water course to help mix, help lift the cuttings. One of our bits that are commonly used down in Florida is our 3 7/8 and 4-inch bits. We use a 1/2 inch button, same design, same concept, only it's nice and small. You can carry that in your carry-on luggage if you wanted to. Our most common bit is we call it a flat face bit. You know, a lot of people used to call them Supremes. I think that was because that was a manufacturer's name. So there's a lot of nicknames for products that come up. We just call it flat face because the profile is flat across the bottom of the bit. If you look here, this one has a 2 1/4, 3 1/4 pin on it, which is real common in this size bit around in this part of the country. Up in New York, Northeast, up in Canada, they use a lot of 6 1/8 bits. We use a lot of 6 1/4. These are also available in a drop center kind type or style that have a section cut out in here, which helps cut and mix so that your cuttings in the center kind of have a place to fall into as they lift. Again, that's a personal preference for some of the drillers. Again, we've got our scattered pattern across the face, so we're hitting new ground every time, and the buttons overlap the spinning rotation every time it hits. So it keeps hitting new earth each time. Here's one that's not real common, but it's used sometimes. When the driller, he gets caught where his pipes needs to go down further, but he can't drive it further. This is called an eccentric bit. We used to make these also in the old sputter cable tool style, but this has just been converted to a button bit. And what you can do is you go down, you can pull your pipe back some down in the well, and then you can start your drilling action just below the pipe. You don't want this section here to come up into the pipe and hit on these buttons, because that metal from your drive shoe might cause these to chip and break and catch on this high point of this corner button here, cause those to break. But you just work your motion up and down in that section, and it'll actually undercut that pipe, undercut the borehole below the pipe, so you can get the pipe down to where you need to be with it. Got some wear buttons on the back just for, they don't do a lot, but they're just wear just to keep this side from getting worn down over time. There's not any real drilling action on the face. Sometimes there can be, but so we've got our pattern for actually drilling if you need to drill with this eccentric bit. Since your tools are offside, it'll tend to make a bigger hole. Even if you was just drilling with a bit like this, it would tend to make a little bit bigger hole. I wouldn't recommend it, but you can, and people have drilled with some of these, but these are designed mostly for undercutting pipe. Our buttons are pressed in, they're nice and long. The ones for the larger bits are 1 1/8 inches overall, so you can see we've got probably 7/8 of an inch that's pressed down into the metal, and we use a press fit on this button of 2.5 to 3/1000 press fit. They're not coming out. A lot of the problems we've had in our learning curve is when we were working with the tolerances for the pressing, you know, we could have some buttons come out, and which is not good. It doesn't it doesn't look good, and it doesn't make us feel good when a customer calls in and says his buttons are coming out. But we've got kind of got all that tuned in, and we press our buttons in using our hydraulic press, one button at a time. It's not a gang press. We line each button hole up with that perspective button and then press them in. The gauge buttons are also pressed in 2.5 thousandths tight, and on a 9/16 hole, that's tight. So we've got a pretty good makeup here with our button bits. Again, like we use our API standards. We can put any thread you want to on a bit, but normally they've got an API standard of 2x3, 2 1/4, 3 1/4, 2 3 3/4, 2 3/4, 3 3/4. The small ones, 2 5/8 joints for 5-inch holes. We go across the scale. If you wanted to put a pipe thread on there, I'll do it. You know, if that's what you want, I'll do it. So I've got one in the lathe back now. The customer called in, and we didn't have one on the shelf for his particular joint size that he wanted. And I have no problem. I'll just throw her up in the lathe and cut a new pin on it and get you running. You won't have to wait till we get some more bits made.